I want to begin today's lesson by looking at the area of an oblique triangle. Now remember, area of a triangle is half the base times the height. In other words, half b times h. In the triangle that I have a base, and if we let side AB represent the base, we could also say that C is the base. If I drop a perpendicular from angle C to side C, that is our height. Now let's see if we can come up with a formula that will allow us to find the area of this triangle. So if the area is half the base times the height, in this case, our base will be C. And let's look at a couple of different ways that we can figure out how we're going to say what h is. If we let beta be our angle here, if we're going to look at angle B, we know that the sine of angle B is equal to the height opposite over hypotenuse. So if we solve here for the height, we get that the height is A times the sine of B. And we can plug into our area formula. Area equals half of the base, which we said was C, times the height. Or we might want to say that it is 1/2 AC times the sine of B. Now we could do exactly the same thing looking at angle A. We could say that the sine of angle A is equal to height over side B. So the height equals B times the sine of A. And if we wanted an area formula here, area equals 1/2 of C times B sine of A, or I'm going to rearrange my letters. So here is an area formula. Depending on which sides and which angle you are given. Area can be 1/2 AC times the sine of B, 1/2 BC times the sine of A, or we could do the same thing and let one of the other sides of the triangle be the base, but hopefully you could guess that at this point, the third way that we could get the area would be 1/2, if we got the sine of C, we'd have AB times the sine of C. So that's just depending on which side you're given and which angle you're given as to which of these formulas that you want to use. They all work exactly the same way, and you could get them the same way by finding the height of the triangle using the angles. If I want to find the area of a triangular lot, the area of a triangular lot whose sides, two sides are 90 meters, 52 meters, and the included angle is 102 degrees. Well, the area is half of 90 times 52 times the sine of 102 degrees, which is approximately to the nearest meter 2,289 meters squared. Now I want us to look at a couple of application problems. Here we have a problem that says a pole tilts toward the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So we figure, since we're in the law of sines, we're going to be using the law of sines. Let's see if we can draw the picture. If the sun is over here, there's our beautiful shining sun, and the pole is tilted toward the sun at an 8-degree angle from the vertical. Okay, so let's say here's our ground. Vertical would be straight up, and we're 8 degrees from the vertical. So the pole's like this. This would be our vertical. And the shadow is 22 feet long. And the angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. That's the angle of elevation. If the pole is tilting toward the sun, 8 degrees from the vertical, well, vertical would be 90, so this angle has to be 98 degrees. And we want to know how tall, or what's the height of the pole. So in this case, we have two angles, and we have a side that is opposite the third angle. The first thing that we need to do is figure out what is that angle right there. And we know that that angle is 180 degrees minus 43 degrees plus 98 degrees, which is 180 degrees minus 8 and 3 is 11, 141, which is 39 degrees. If I did that correctly, I think I did. Okay, so now we have the side opposite 39 degrees. We want to find the side opposite 43 degrees. So move this all up just a little bit. And so we can take, we're looking for the height. So the height over the sine of 43 degrees is equal to 22 over the sine of 39 degrees. And of course you have to use your calculator. You have to be in degrees. If we multiply 22 times the sine of 43 and then divide by the sine of 39, we find that the length of the pole is approximately 23.84 feet. Okay, anytime you're doing an application problem, if they give you units of measure, be sure that you use your units of measure. All right, let's look at this other application problem. Here we're bringing bearing back into the situation. It tells us that the course for a boat race starts at A and proceeds south 52 degrees west to point B, then south 40 degrees east to C, then back to A. Point C lies 8 kilometers south of A. Approximate the distance of the course. The first thing we have to do is take it step by step and draw what we are given in the problem. So if we're starting at A, and we are going south 52 degrees west. Remember, when we're talking bearing, it's always off of a north-south line unless you're talking airplane flight. So if it's 52 degrees west of south, it's going to look something like that. So we're going, maybe it's a little bit, probably needs to be more of an angle. So let's just say that this is 52 degrees. Right here, 52 degrees. And we don't know how far we go, but we go for a while. I'm going to make it big enough so that I can draw my triangle to point B. And then goes south 40 degrees east to point C. So I'm going to draw my north-south line, or just kind of pencil it in. And we're going 40 degrees from the south line to the east. So if that's 40 degrees, we're headed this way. And we're told that C lies 8 kilometers south of A. So here's C, and we know that this is going to be 8 kilometers. So what I've got to figure out, we know that this is angle 52 degrees. We have two parallel lines cut by a transversal, so alternate interior angles are congruent. This is 52 degrees, and this is 40 degrees. So we can find the inside angle, 180 minus 92 is going to be 88 degrees. And then we can find angle C. We have 180 minus 10, 140 degrees. So C is 40 degrees. All right, so we want the total distance of the course. We have one leg of the course, that's 8 kilometers. So we've got to figure out what is side A and what is side C, and we can do that using the law of sines. We know that side A over the sine of 52 degrees is going to be equal to 8 over the sine of 52. I'm sorry, over the sine of 88. And so when you plug that into your calculator, you should get that A is approximately 6.31 kilometers. We can do the same procedure to figure out what side C is. Let me move this up just a little bit. Side C is going to be C over the sine of 40 is equal to 8 over the sine of 88. And when you plug that into the calculator, we see that C is approximately 5.15 kilometers. And so if we want the distance of the course, we're not done, we want to add those together. So we've got 6.31 kilometers, 5.15 kilometers, and 8. So 19.46 kilometers is the approximate route of the course.